for breaking news. Class report is about to start. Let's hear to Miss Michelle.
Thank you, Ms. Morris. Good day, everyone. My name is Michelle, and my topic is all about traditional and object-oriented views of activities. So, let's start. Our main topic for today is about traditional approach to requirements. And my topic is about views of activities of these two approaches. Before we start, let's have some idea what is traditional and objective-oriented approach. Traditional views as a collection of processes, and object-oriented views as a collection of interacting objects. These two approaches used for system development. Let's go on to the views of activities of these two approaches. The traditional approach views a system as a collection of processes, some performed by people and some by the computers. Traditional computer processes are much like procedural computer programs. They contain instructions that execute in a sequence. And next, object-oriented approach. Object-oriented views as a collection of interacting objects that works together for the analysis, design, and programming. And the uses of these two approaches will be discussing of the next reporter.
Thank you, Miss Michelle. Now let's hear the second report from Miss Melissa.
Thank you, Ms. Morris. Good day, everyone. Before we start, let me introduce first. I am Melissa Sarmiento, and then the continuation of our presentation is about the use cases of traditional and object-oriented. So let's start. The use cases of traditional and object-oriented. So we have here what is the use cases of traditional and object-oriented. Second is elements of object-oriented system. For the third, features of object-oriented system. And lastly, operations performed on objects. Next is traditional and object-oriented use cases. First, traditional computer processes are much like procedural computer programs. So means they contain instructions that execute in a sequence. For the second one is it interacts with stored data, reading data values, and then writing other data values, and then back to the data file. So means the process might also interact with people, such as when an instructions asks a user to input a value, or it can be display information to a user on the computer screen. Some other explanation, the traditional approach to systems involves processes like store data, inputs and outputs, and also includes processing models that emphasize the system features. So next is elements of object-oriented system. First is objects, something that exists within problem domain and can be identified by the data attribute or behavior. So means all tangible entities like student, patients, and some intangible entities like bank account are modeled as object. Next is attributes. Attributes, they describe about the object, and also attributes also describe an information about the object. Next is behavior. It defines the operation performed on objects. So means it specifies what the object can do. Next is class. Encapsulates the data and its behavior. So means an objects with similar meaning and purpose grouped together as class. Next is methods. Determine the behavior of a class. So they are nothing more than an action what an object can perform. Next is message. Is a function or procedure called from one object to another. So for the message, they are information sent to objects to trigger methods. So next, features of object-oriented system. This object-oriented system comes with several great features which are discussed below. First is encapsulation. It is a process of information hiding. So means it is simply the combination of process and data into a single entity. Next is abstraction. It is a method and attribute to specify the object. So means abstraction can be process of taking or selecting necessary. It also focuses on essential characteristic of an object or related to perspective of a user. Next is relationships. It is related to the system with each other, and also relationship objects do not exist in isolation. They exist in relationship with other objects. Next is inheritance. It is used to create subclasses from an existing class. And also inheritance, it is a great feature that allows to inherit the attributes and operations of an existing classes. Next is polymorphism. It is the ability to take on many different forms. Polymorphism, it applies to both objects and operations. Next is operations performed on objects. First is constructor or destructor. It is to create new instances and deleting instances of a class. Example of constructor and destructor is by adding a new employee. Next is query. Accessing state without changing value has no side effect. So for query, for example, finding address of a particular employee. Next is update. Changes the value of one or more attributes. And example of update is changing the address of an employee.
We're done about traditional approach and objective-oriented of activities and use cases. Now, let's move on to the last report. Today, we're talking about data flow diagrams. We'll examine what they are used for, what the various symbols and notations mean, and take a look at how to get started building them. A data flow diagram illustrates how data is processed by a system in terms of inputs and outputs. As its name indicates, it's focused on the flow of information, where data comes from, where it goes, and how it gets stored. Let's explore the common data flow symbols and notations, and what they signify. Data flow diagrams become popular in 1970s in software development. They were first described in a classic text about structured design, written by Larry Constantine and Andy Ordon. This is a process notation. A process transforms incoming data flow into outgoing data flow. Here is a data store notation. Data store are repositories of data in the system. They are sometimes also referred to as trust files. This is a data flow notation. Data flows are lines through which packets of information flow. Level the arrows with the name of the data that moves through it. Here is an external entity notation. External entities are objects outside the system with which the system communicates. External entities are source and destination of the system, input and output. Data flow diagrams also have levels or layers to help organize the data. A context diagram is a top level, also known as level 0 data flow diagram. It only contains one process node, process 0, that generalizes the function of the entire system in relationship to external entities. The next layer, level 1, should illustrate a more detailed analysis of the data in your context diagram. From there, you'll go into still more detail in level 2 and so on. For the next level, break down your process. Data flow diagrams are pretty easy to construct using an automated diagramming tool like SmartDraw. This will provide all the necessary data flow diagram symbols and easy-to-use templates that help you get started. Just drag and drop shapes. where they need to go, and type to enter data. You can nest the different level of your data flow by using hyperlinks.